Okay, in this problem here, we've got a continuous variable x with the probability density function defined as little f of x here. We want to, in terms of a, determine the cumulative distribution function of x. Well, let's think about what cumulative distribution functions are and what little f of x is, the probability density function is. If I consider this function here, I know that at 1/2 it goes like this. It's a function like that. And this value here is 1/2, and this is 1/2 as well. 1/2 as well. Okay, and it's just a straight line. And then I have a quadratic function. So it's quadratic. I know it's been shifted over 1/2 and up 1/2. And so it does this kind of quadratic. I don't know what the stretch is on A, and this goes up to some value of 1. Now, I'm not quite to scale here, but you get the idea. And the cumulative distribution function basically starts to add up this area underneath the curve. And it's all based upon where x is here. And so it's, as x goes long here, it accumulates area. And so the CDF, or the cumulative distribution function, is all about the area under little f of x. And that's going to be our big f of x. And so we need to integrate these functions. So if we have that in mind, I know if I'm going to consider, first of all, from 0 less than x less than 1/2, if I want big f of x, well, I'm going to integrate from 0 to some value x, this is x, for some function 1/2, and we'll just call it dt, and t is just a dummy variable. When I integrate that, I get 1/2 t, and that goes from 0 to x, which is then just 1/2 x. And so creating my big f of x function, my cumulative distribution, I know it's 1/2 x from 0 to 1/2. 0 to 1/2. Now, if I want to check that, if I want to do f of 1/2, well, if I plug in 1/2, it's going to be 1/2 times 1/2, which is equal to 1/4. So thinking about the graph up top here, if I go up to here, this entire area up to 1/2 is going to be 1/4, which makes sense from my area of the square. Doing the second part of the function, though, if I want to consider the function now from 1/2 to 1, well, if I'm going to find that function, I know I first have to add the 1/4, and then I'm going to have to integrate from 1/2 to x as I accumulate area here of my function, which is a quadratic here. And so now I'm going to go from a, x minus 1/2 squared plus 1/2 dt. And I'm going to make this t, so I'm just do proper notation, because even though this is the x that's accumulating, and I just need something to hold the variable spot. And so now when I integrate this, I get 1/4 plus a, and then I have, well, this is going to be t to the 1/2 cubed, and then 1/3 plus 1/2 t, and that is going to go from 0, oh, no, not 0, rather 1/2 to x. And so now if I expand this, I get 1/4 plus a, oh, I have to be careful with my a. My a should not, my a is only on the first part. I cannot take it out of my integral here. Let me just be careful here. Do it correctly. So this a cannot be out front, but rather it needs to be inside the integral here. So here's A, here's A. And so now I get A cubed, plug in my x minus 1 half cubed plus 1 half x, subtract, plug in the 1 half, well, that's going to be 0 minus 1/4. Then taking off the brackets, these 1/4s here, they subtract away, and so I'm left with a cubed x minus a half to the power 3 plus 1 half x. And so then if I finish off my function, then it's going to be a over 3 x minus 1 half to the power of 3 minus 1 half x, and this is over the interval, less than x less than or equal to 1, and 1 otherwise, because if it's after that point, it's just already equal to 1. We're not going to do more than that. All right, so there is our cumulative distribution function, all worked out for us. Now, B part says show that A equals 12. Well, in order to show that A equals 12, I'll come back, is what I do know for B, I know if I do f at 1, because that's the end of my interval, it has to equal 1. So let's plug this value in. So it's a over 3, 1 minus a half cubed plus 1 half times 1. And now if I solve this, I get 1 is equal to a over 3. This is 1 half cubed plus 1 half. 1 half. And if I solve it, I'm going to subtract 1 half. So I get 1 half is equal to a over 3 times 1/8 is a half cubed, multiply by 24. And so I get a times 24 is equal to, oh no, it's not, a over 24 is equal to 1 half. And so clearly a is equal to 12. And so now I have the cumulative distribution function in terms of a, with a being 12. Okay, so now moving on to the next part, we were asked to find the expected value, and we know from our formula book that this is the expected value for the continuous random variable, and we must use our formula little f of x for this scenario here. So from these two formulas, setting it up for C part, if I want to find the expected value, well, I know it's going to go from 0 to a half of x times 1 half dx plus going from, well, I know a is 12, x, using our formula, x times 12, x minus a half squared plus 1 half, and this goes from a half to 1 dx. This is the computation I have to do. And because it's paper 2, or paper 3, sorry, for this option, I always have my calculator. So let's put it into our calculator and just do the calculation. So it's math, it's number 9. I'm going to go from 0 to 0.5, x 0.5 dx, plus, again, math number 9, from 0.5 to 1, x, and I've already taken the liberty of putting it into y1, this particular function here, or I hope I have, and I'm going to do it to x. And when it's all said and done, I get 0.6875. And marks for this problem would be the setup and the answer, really. You don't have to do this by hand. You're expected to use your calculator, would make it an easy way to get your points. And then finally, D part from the problem is asking us to calculate the median m of x. Well, I know if I'm going to find the median, my cumulative distribution function, this particular function, I want to add up all my area. I want to add up my area, and I want this to be equal to 1/2. And so what I'm looking for is I want f of some value m equal to 1/2, because that's what median is. It accumulates up to 1/2. Well, I already know that this is going to be less than 1/2, since if I put 1/2 in there, it's going to be a quarter. So I'm going to set it equal to, well, that's 12. 4, 12 over 3 is 4. Oh, m, because I'm looking for m minus 1/2 cubed minus 12m. This particular equation here, again, use your calculator, solve it, and you should get m to be 0.795 to 3 significant figures.